Hi, very good evening, everyone. Hope we can start this session. Yasir sir, can you?
Yes, sir. Okay. Good evening to one and all. I hope everyone is fine. And I think today is the last session of our FDP. So I hope you got an overview towards the AI and its various techniques. So today, so before that, just is my voice audible and is visible? Just type yes in the chat box so that I can know. Uh, okay, thank you. So neural networks. I hope you have heard regarding this neural networks. So neural networks is a machine learning model which is inspired by human brain. It consists of many interconnected artificial neurons that processes the information and it learns patterns from the data. Patterns in the sense it can be, so if you're considering an apple or an orange or a dog and cat. So for apple, it can be the boundary, or it can be the textures, or it can be any of its features, which may be the pattern learned by the networks. So actually, it can learn any patterns mathematically, but it depends on the training. It depends on the epochs given during the trainings. So that's it. So like in the first class, I think I have said you how the babies learn an image or how the babies learn what type of learning process is happening in the human beings or the babies, so you can compare like that. So human brain, you have a biological neuron that is actually communicating using the signals. So whatever input you are giving, that input in our brain, it is classifying whether it is a cat or a dog or an image or whatever it is. So it depends on our uh, training happening in our brain actually. So that can be mathematical or some other uh, electric or trigger pulse given in the brain. So usually the basics of neural network is happening in mainly in side, and application is you can think of the object detection, then segmentation, or even for image recognitions, usually for faces, objects, handwritten digits. The example which I can give is the self-driving cars, or in your mobile phone you have face unlock phones. So these are based on neural networks. And I hope in your mobile you have speech recognition. Your speech is converted into text. So there you have Siri, Alexa, Google Assistants. So these things, what is it's actually doing is it takes the input and performs some hidden calculations or some of the mathematical steps, and it produces an output. So and that is known as neural networks. especially in NLP and all. We have translation, text summarization, ChatGPT, this OpenAI and Google Translate stuffs. Even in medical diagnosis, you can detect the X-rays, MRI. Even I think doctors are also, or the lab technicians are also using AI to detect the parts of the cancer or tumor or some other medical reports. Even in recommendation systems, you can see the YouTube recommendation in your own ID, Netflix movie suggestions, Amazon product suggestions, and nowadays Tesla and uh, what do you say? Google have autonomous cars. Here, neural networks only helps the drivers, or I mean, the automatic vehicles to detect the roads, recognize the traffic signals, avoid obstacles. You have data from the sensors, uh, then it performs various operations. So that is happening. So especially the trying for the history of the neural networks. So it was uh, like evolved over many decades, inspiring the human brains. So biological inspiration was by I think 1940s. So scientists wanted to imitate how the human brain works. Then how the human brain contains billions of neurons. Actually, they were trying to detect those things, those stuffs. So biological neuron was the inspiration of artificial neural networks and all. And by 1943, I hope you might heard this McCloch and Pitts neuron. It was the first mathematical neuron processed by McCloch and Pitts. They were two scientists. So they only actually introduced the simple artificial neuron. So they gave a weight as I mean, they gave an input and an output was produced actually. So then they calculated some functions which directed or which mapped the input towards its output. So this became the foundation of the neural networks. That was by 1943. By 1957 only this perceptron concept came. Actually, it was the first learning neural model network. The capabilities at 1957 was it could classify, I mean, the binary classification was there. Binary means 1 0, or you can classify between two classes only. Nowadays, you have multiple classification. At that time, only binary classification was there, late 1957. So it learned the weights automatically. Weights means you can think of the patterns or the textures or boundaries or edges or whatever it is for detecting an object. So there was some perceptron learning rules, and the limitation was it could not solve some of the problems, especially the XOR problems. I'm not moving directly deeply into it. Then only the back propagation in the current deep learning methods. It was one of the best algorithm, which insisted the feedback networks. So that solved many of the problems. And finally, by 1990s or 2000, only this convolutional neural networks came. So now that is trending. Uh, it became successful in handwritten digits, then image processing, then in then finally by 2010 2015 only this deep learning revolution came. Large data set was given into GPUs. Internet data caused major breakthroughs, and important researchers like Google, Meta, then Amazon, then most of the IBM, these researching companies did expansion in computer vision, speech recognition, NLP, and this was a and I think by 2012 the ImageNet dataset came. The model was AlexNet. It was created by this Alex and Geoffrey. They only introduced this image classification or the object detection. From there only by 2012 only this AI boom came. And today the neural networks give the ChatGPT, self-driving cars, then medical AI, generation, the technologies like the new convolutional neural networks, then RNN, then LSTM, and lately by 2020, I think Transformers. That is, attention is all you need. That is the paper of Transformers. It gave for open AI, ChatGPT, then BERT models, large language models, everything. So you can think the timeline was by 1940s, the McClush-Pitt neuron came. By 1950s, the perceptron came. 1970s, the limitation of perceptron declared. By 1980s, only the back propagation, which was widely used nowadays in deep learning, that algorithm came. Then by 1990s, 2000, the CNN, convolutional neural network, which is very famous nowadays. Each and every student or each and every industry, they are using convolutional neural networks. And by 2010, this deep learning revival came, and by 2020, 25, and all the advancement in different AI technologies came. So the each and entire basic things computed is something like neural networks. So that is something made the evolution in the entire history of. So basically, neural networks, you can think about it's a machine learning model inspired by human brain. It's made up of some connected artificial neurons that learns patterns from the data, as I said earlier. So you can the human brain is processing the signal. Artificial neural networks is calculating the numerical data, or it is converting each and everything into the numerical, or even the images or videos or whatever it is, everything is converted into numbers. So that's what it's available for us, right? So we cannot do the hidden magics which is performing inside the brains. We can do maximum is mathematical calculation. And for doing this mathematical calculation only, we are using this GPUs or whatever it is, whether it is the quantum computing, which is evolving between last 5 years, or the GPUs which are coming, that only we can do. And other all things which are in the higher dimensions, we may be not able to perform, or we may be able to perform only the mathematical calculations. So you can think, receive some input data, and in order to map the data, so whether if you receive a image of dog, you want to uh, classify that image of dog as a what dog means, you need to learn the patterns, you need to learn the textures, you need to learn the hidden features inside that images. So that is basically our artificial neural network is learning. So you can think of, you are receiving an input data that may be something like image pixels, or some type of values from the sensors, or some type of values of the any textual data, and you are just passing it to the hidden layers inside the neural networks, which learns the patterns or the features from the data. So, and it produces a final prediction, whether it is a cat or a dog or an apple. So here, mathematical calculation basically it's coming. So you can think of, as I said earlier, uh, the biological neuron. So actually, the neural network, it was an inspiration from our biological neuron in humans. So you can, I hope you know what is a biological neuron. So it's a nerve cell in the human brain and the nervous system. So it's a basic unit responsible for thinking, learning, memory, then movement, communication. Then human brain like contains approximately 86 billion neurons. So these 86 billion neurons only calculating, or it's the entire process of human being is happening. Even if one neuron is failing, that might cause for the what do you say, some type of damages in the body. So these 86 billion approximate neurons are performing the entire, like I said, let's say the like thinking, learning, memory, movement, communication, each and everything. So I hope you know the parts of in the diagram. You can see the different parts of the, I mean, biological neuron. So I hope you know it have dendrites, then cell body, nucleus, then the axon, many things it's having. So the inputs are actually received in the dendrites. So dendrites only actually receiving the signals from other neurons. So it's like a chain service. Or you can think like antennas collecting the signals, receiving the information, incoming informations. And the cell body you can see, it's known as the soma. the cell body receives the information. It contains the cytoplasm and the nucleus. It acts like the control center. So then the nucleus controls the neuron activities. That only actually contains the genetic material DNA. What is long cable-like structure? It is called the axons. It carries the electrical signal away from the cell body. So the axons are very long. So it's having in the axon terminals also. It transmits the signal from one neuron to next neuron. So that is actually happening. Even the tiny gap between two neurons, the communication happens here using the chemical called neurotransmitters inside the body. So what is happening? The signal, you can think of the signal received by the dendrites. It is processed in the cell body. The electrical impulse travels through the axon and signal reaches the axon terminal and transferred to the next neuron. This finally only brain. So in artificial neural network, you can compare it actually. So you can see a small image. Similarly, it receives some inputs in the biological neuron. Artificial neural networks receive some inputs. You can think of X1, X2, X3, whether it is the pixel data of the images, or whether it is some values from the sensors, or whether it is in textual data, whatever you give to the input. So dendrites, dendrites receive the signals in biological neuron. Artificial neurons receive the inputs from the data. And in the biological neuron, the synapses are having special strength. Here in artificial neuron, we give special weights for each input. So this thing you can compare with what, like I'll show you. And then the cell body processes the signal. You can think the weights given to the input is calculated by the perceptron. I'll show you how it is happening. And finally, an output is generated. So this is actually happening. So you can see like the dendrites in the neuron receives the input. The input is received from various parts of the electronic or mobile or whatever equipments or sensors or whether it is computation. So then each input it's having its own weights. So then some hidden calculation is happening, and then only we are getting the output. So this is the entire process of artificial networks. So it receives some form of input. So you can see here, we receive some form of input, x1, x2, x3, etc. And then it is combined by some weights. So this you can term like a linear regression equation, like y equal to mx plus c, or y equal to m1 plus y equal to m1 x1 plus m2 x2 plus m3. So you can compare like that. So like this weighted sum only is happening, then it is passed. So we receive an output. And for activation, so it depends upon each application what is the activation functions. So main peculiarity in the neural network is this activation function. I hope you can see my screen. I have given it very small. I hope you can zoom and check. So activation function only decides whether the output, whether a neuron should activate and pass the information forward. So without the activation function, a neural network behaves like simple linear mathematics and cannot learn the complex patterns. So this you can think of linear regression or something else, or something like linear mathematics. So then we are passing the output. So like y equal to mx, we are passing this y into some other function to get some complex structures. So that is what it is doing for the images, videos, audios, etc. So you have x1, x2, x3, etc. up to as the input, and you have y as the output, and you have w or omega or m1, m2, m3, etc. for the weights. So actually, why activation functions are needed? So without activation, you will get some linear equations, right? Whether it is a line or a plane or any hyperplane, you can do only that conversions. But if your function is very tough or very complex patterns, you need to provide respective activation functions. So the network can learn the complex non-linear patterns. So linear means it's just like I shown you what is a linear regression or something like naive bias and those type of SVM. So those types are linear patterns. What if something like complex non-linear patterns like quadratic or cubic? So I hope you know the quadratic functions, U-shaped functions, right? So what if something like that came? How can we do? So this is how we introduce this activation function, especially for image recognition, speech recognition, then NLP, that is then medical diagnosis. So this is happening. So we have different activation functions. So that is actually putting something. So here you can see we have an x1, x2, then we are giving proper weights. So actually these weights we have to learn. This is the weight which we have to learn actually. So basically neuron function. So I hope you understood these things. If you have any doubt, you can ask me. So basically mathematically, uh, you can think of these things as a basic function where you receive some inputs. Okay, so you can see the inputs given by x belongs to r power n. So it can be any dimensional. So n r power n means it's a real valued number with any dimension. So a neuron can be viewed mathematically as a function. You can see with a vector x with different dimension. Then it into a hidden function. So you can think the x contains n real valued numbers. Then where x is a vector. So I hope you know what is a vector. So vector has different elements like x contains x1, x2, x3, and so on. So if neuron receives different inputs and then some transformation is happening with the function and it is mapping into the respective outputs. So output is single dimensional. What you can say, you can classify into different vectors or whether matrices or that forms. So neural networks actually is something like graphical structure where many is happening. Okay, so each edge by edge is happening with different functions, inputs, outputs, and those things. So, so you can see here we receive many input, we receive many output. Some function it is happening actually. So it's a basically we are terming it as perceptron. So actually, what is a perceptron here? So you can think a perceptron is something like it performs different calculations. It's a fundamental building block of artificial neural networks. So it was invented very early. It's a supervised learning algorithm you can think of used in mainly single perceptron. You can do it for binary classification. So it actually mimics the what you say uh, uh, like biological neuron by taking multiple inputs, applying weights and summing up and passing the result through the activation. So how it works, you get some raw data features. You can think of it's a pixel of an image or a characteristics of house or whatever it is. Each input is assigned a weight that determines the importance of the final decision. So you saw here. So let me, yeah, here you have some inputs dependent on the importance of the inputs. You have proper weights w1, w2, w3, and this is given to the function actually. And the summation, the algorithm calculates the weighted sum of the inputs, often adding a bias to shift the boundary. I hope why we are adding the bias, you can think of a y-intercept. We want to shift the decision boundary. That's why the mathematical formula is coming like something like w1 x1 plus w2 x2 plus w3 x3 etc. And some function is happening inside. So basically a perceptron, you can think of a simple artificial neuron in a neural network. It takes the inputs, multiply them by weights, add them, and produce output. So similarly, like human brain neuron, you can think of it's receiving signal, processing the signal, sending the outputs. Similarly, artificial perceptron, we are doing it mathematically. It receives some inputs, some function it is processing and giving the prediction output. So that is what is happening. This basically you can think of in linear algebra, it's a dotted product. Here we are taking dotted product like z equal to omega x, and then we apply some activation. So if the result, you can think like, for example, if the result is positive, the neuron fires, else the neuron doesn't fires. So that is happening in the side of the neural networks. So I hope you understand. So like this only the evolution is different technology came, like neural networks, then the perceptron. So perceptron was for normal binary classification. So like I said, what about if uh, some complex patterns came, like graphs like cubic, quadratic, or something else? So that's why the introduction of multi-layer perceptron came. Then autoencoders came. Then convolutional neural networks came. Recurrent neural networks came. So for the limitations in the recurrent neural networks, the LSTM came. So LSTM was widely used by the applications. So we don't have that time to introduce more. But so I hope you know the modern technologies like transformers, then generative adversarial network, that is known as GANs, used in chat GPTs and for image to text to image conversions and all, and even graphical neural networks. The entire thing happening in the neural network is the basics of the biological neural network only. And that's why mainly the multi-layer perceptron came. So multi-layer perceptron was one of the most basic and important types of artificial neural networks. So I hope you understood the single perceptron. So if you have any doubt, so single perceptron, you can think of, you have some input, then it is converting into some output. So multi-layer perceptron means it has many layers. You can see here I have shown many different layers. So each layer acts as each function to convert into responsible output. So for normal conversion, you can think of some x. It is performing something like linear function like y equal mx plus c, and it's converting to the output. That you get y from that one. So what happens if the computation is very high? If some toughest patterns comes, that's why we are using the multi-layer perceptrons, because it has multi-layers. So multi-layer perceptron, you can call it as like something like vanilla neural networks. So because it is the simplest fully connected neural networks. So where you have some input, then some weights, and then you transform it to the hidden layer, and finally you get the output. So it will predict like cat or a dog or any digits classification or price prediction or whatever it is. So actually what is known as the hidden layers. So you can see I have, so what is it actually? So without hidden layers, you can think the model can learn only the simple linear relationship. You can compare it to the linear regression what we have studied. With hidden layers, can learn some complex non-linear patterns like handwriting recognition, detection, speech recognition. So we have many activation functions for doing that one. So that is the mainly playing network inside this each and every technologies. So you can think the perceptron here. You can see in this image the perceptron. So there you can see a single neuron, and there is no hidden layers. So basically, you can think of a linear classification like y equal to mx plus c. So you can convert like spam email versus non-spam email, or pass versus fail. So it cannot solve some non-linear problems. So then you can see the feed forward networks. So the data moves only forward. No feedback is there, or no loops or memory thing is there. Mainly used, you can use for classification or regression or some recognition, something like that. Then coming, you have some deep for feed forward networks. So that is something like people usually call deep learning. So image classification. So it is entirely connected actually. Many hidden layers. So then you can see recurrent neural networks, the specialties output from previous step is fed back into the network. So whatever output, so like text processing and all, we use recurrent neural networks. Then we have some special type of recurrent neural networks is LSTM. Then we have something like GRU. You can see here it's designed to remember the information for long time. It solves the many of the problems which was arised in the like RNN. Why means you have some uh, different types of layers, n number of layers. So when you multiply by the small numbers and all, it gets some vanishing gradient problem. So this was solved by LSTM. So finally, then autoencoders came. Then many big networks came, like variational autoencoder. So now only this ChatGPT, the evolution of neural networks to ChatGPT came. So main thing was the evolution was perceptron, then the deep networks, then the RNN, LSTM, convolutional neural networks, which is mainly trending now, and the transformers. It's widely used by the Google, ChatGPT, and those things. Gemini, Claude. So it was the advanced neural networks. And then we have many things like neural Turing's machine, extreme learning machine. So these are different types of like. So now we will check with the multi-layer perceptron. See, I have already explained. So you can see an input image is coming. So in image classification example, you can think of one image is coming. So you know you need to calculate it as per the. So basically, when you're teaching it to students in Python, so you can do it very easily, but you don't know what is happening inside. So these things you have to be very careful. So you give some images, how what is it happening? So you can think the images actually consist of different individual pixels. So when you are buying a camera or a mobile, you will check the pixel quantity, right? So what is this pixel in the images? So what do you mean by, so actually what is it? So pixels means you can think of it's a short for picture element. It's the smallest building block of a digital image. Millions of these tiny colored squares are arranged into a grid to create the pictures you see on the screen or the photos you capture with the camera. So each individual pixel holds a specific numerical value and it dictates what is the exact color or usually the end of the RGB, that is red, green, blue, and the brightness. So an image resolution defines how many pixel it has. If you zoom it extremely, I hope you know these things, basics of image. So if you zoom in image, you can see the clarity of each and every image. So this image consists of individual pixels. Each pixel store as an intensity values. So it's something like it's images are turned into a vector then to pass it to a network input. So when if you want to detect the image's face of a cat, you want to turn each and every pixels as a what do you say uh, intensity values. So each intensity values map it as n plus one dimensional vector. So like you have n plus one pixel intensities, you transfer it to a vector. So each values have different dimensions. So then only you are passing these actually input layers to the next. So actually what is happening is when you are doing it in Python, you don't know what is happening. You are just calling the function and something inside it is happening so that you are not getting what is the actual depth. Especially for students nowadays, the codings and doing the project is very easy. Why means everyone is giving to ChatGPT. So that is also promoted like white coding. But if you're taking it into a research level or a wide range of big applications, you can't do this. So normally, while we do this project and all for students, we expect like 60 percentage result, 70 percentage result, or 80 percentage result. So in India, especially, everything is happening only to 80 percentage. Nothing is happening 100 percentage. We will get very good result, and everyone will publish the papers like 95 percentage, 91%. So to reach it, something like 100 percentage it's very tough. So that is why we need to dive depther into this vectors and matrices, and we have to research on each pixels what is happening and all. So what is in the network output? So actually you need from this image you need to predict it's a cat. So actually what is happening, is it a dog, is it a cat, or is it a human? So normally this facial like structures or fur like structures usually most animals are having, right? So how can we predict what is the important that it is a cat or a dog? And the output is given by something like indication vector. So if the cat is, the given image is a cat, you can think it's a 1, or wherever it is, it will be 1. So that much percentage it should give the results, indicating the output layer is a vector indication of activation functions. So this is happening actually. So actually, what is happening inside? So we can think the computer cannot understand the images directly, right? So we convert this image into matrices or real values. So I think for a grayscale image, you can think this is a grayscale image, right? So we have to r the height power, height into width dimensions. So you can think of a matrix, and then we are flattening the image into a vector. So that is what is happening here. So we are flattening this matrix into a vector. So the image matrix becomes something like you see like a 3 by 3 images forming a n by 1 vector. And the neural network, what is it happening? I'm sorry. Neural networks, what is it happening? So you can think of it's calculating a mathematical function. We are mapping this input image vector x into the output predictions y cap. So you have different layers. In each layer, you calculate some functions. The function may be a linear function or a non-linear function. So it depends. So you're converting this pixel intensities into some output. So that is happening here. So that is actually the multi-layer perceptron looks like. So what is happening? You can think like the input is given to a layer, and you are calculating those input to map it into an output. So each layer it is happening. You can see here. Then you have respective weights. So for input x1, x2, or a1, a2, a0. So whatever it is, you can think we are giving x1, x2, these pixel values, and then we are classifying it into different outputs. These outputs are then again passed to different layers to get the respective outputs. You have some respective weights here. Why you are giving weights? So each weights you are changing it during the training using the feedback networks. So why you are changing? You want to know which pixels are important to predict respective uh, uh, images as cat or a dog. So you're giving importance. So if the first pixel is not important, you will train the network as 0, so that it multiplies by 0. So this is actually happening. It's activated through a weighted sum of input activations. So that is what you give here. So if let's think that the first you can think the first pixel intensity is something like not important, the training will give the weights as 0. That is actually happening while training. So that you can start with a random number, and you have to compare the input and output. You can give it's using the different functions. So this is happening inside the training. So actually this part looks like a convolution used for defining the local parameters. A linear shift in wherein kernels is operating. If you know the term convolution, I think some of you know regarding the convolutional neural networks also. So this is happening actually. So basically you can think of uh, why it is happening. So you can think like we want to map some functions into different outputs. That is actually happening here and all. So the mathematics side, you can think you're receiving some inputs, multiplying each input by a weight. So that's what I was showing here. Then adds everything. That is the weighted sum. You are adding everything in each and every layer. You're adding the bias. Bias, we can think of the y-intercept. So this you can think like y equal to mx plus c, or a equal to w into a, something like that. That means what is happening is like it passes the result through different activation functions and produces the output. So the weight tells us the importance of each input. If this pixel is not important, means that will be 0. If some other pixels, a1 is the biggest pixel to predict the given image is a cat, means this will give more importance. And that is what is happening in linear regression also. Large weights means important, it's an important input. Small weight means less important, and negative weight means you can think that it is suppressing the signal. And this is happening like weighted sum. So that is what is happening. Okay. And coming to the activation function, so this acts like a dot product. So I don't know how many of you know this linear algebra. You study this dot product. So you can think like z is z equal to, or the output equal to w transpose a. So you are adding some bias, then it is something like w or z equal to, or a equal to w transpose a plus b. So bias, you can think like it's a shift that you need for neuron activation. So think of like something like threshold adjustment or extra flexibility with. So without bias, the decision boundary always pass through the origin. So if you want slight higher shift means, or linear shift means, the bias helps neuron learn better. So actually you can't think depth into these things. So what is happening inside? So in Python, you need to call. And so let's do an example in the collab. Let me take the collab, so you can know what we are happening, what these things are doing. So in collab, actually you need to just, you can load the data set. So let it load it. So you can, let me try with the data set which is there in syllabus, that is MNIST data set. For MNIST you need something like OpenNML data set. So let me fetch that one. So you know the code. I hope you know sklearn.dataset to fetch the data sets. You should not forget. So you can import the OpenML dataset where you get some MNIST dataset. So OpenML. So fetching the dataset. So actually, the OpenNML datasets. Let me give an introduction for that one. So it's a dataset provides training data for various machine learning models. So actually, what is it? What it contains, you can think of. So it's a publicly uniformly formatted collection of data used for various research purpose. So you have various number of data set in that one. So mainly number data set, digit data set, then you have alphabets data set, then many things you have like monks, blood transfusion data set, then something like steel please fault, and many types of data set you have. So now I am fetching the MNIST. So MNIST, what is MNIST? So it's a modified National Institute of Standards Technology database. It's a, you can think of a hello world of machine learning. So it's a mass standardized collection of 28 by 28 pixel grayscale images of handwritten digits, like 0 to 9. So I'll display. So you can see, so actually basically the image dimension of each image in this data set is something like 28 by 28 pixels. And the class is 10, like 0, 1, 2, 3, 4, up to 9. And the training set is 60,000 images. And the total data set size is 70,000 images. So basically, it is a standard baseline used to evaluate whether a new neural network or computer vision framework or machine learning model is working correctly before moving on to larger data set. So that is MNIST. So it's one of the most important data set in the Python. Okay, so let's see it or utilize it. So let me load it actually. So you can load the MNIST from the OpenML. So it's the function fetch ML, fetch underscore oh well, fetch MNIST, MNIST, and 784. You have different types of images there. And let me type it. We need the version 1. I'm typing the version equal to 1. So it depends. So like this, I actually define some different types of data set. And we have different types of MNIST also. MNIST data sets. So you can find out in the Google to display those things. Okay. So this fetch ML is something I have shown you for this basics also. So this is how you load images. So now X as the features. I hope you know what are the features. That is how you load is mnist.data. This is what we have class also. Y, this is the target outputs. So that's mnist dot. So this is how you load the data. So this things are very easy. So now you can see we can display some. So let me display an image x equal to will display the image x dot. This is the code to display an image I log. So let me take it and let me check. Yeah, so it will take some time, and you can display the using the PLT. This is the code to display image. So I hope you know these things. Image PLT is not defined. Let me find that. So this is the errors while you import you need mat.lib dot as PLT. So actually it's an shape. I need to reshape it actually. Let me reshape it. You'll find out these errors while you're doing also. So you can reshape 28. So now you can see. So I think this number 5 or something else. So you can display different numbers. So actually it consists of different data set like 70,000 images. So you can see, right? So this helps us to view. You can display different numbers. You can see. So MNIST, it's a data set. So what is actually MNIST? It's a handwritten data set. You can display here actually. You can check. So I'll share you the codes, no worries. Okay. You can see. So it's a famous data set. Mainly you have handwritten digits, correct digital digits values. Then it's mainly the beginners use it to learn the perceptron or neural networks or the convolutional neural networks. Those types of basics. So you can see many types of images here. So that's why I have given a display for you. So let's perform some types of training here using some perceptron. So what I have shown. So basically, let's split the data set before training. So you can think the explain x underscore train. So this is the code we use for that training splits, or you can train with the entire data. It doesn't matter, but you need some entire data if you're giving for the training. But it won't be a you need to keep something for testing also, right? To test the accuracy and those things. So we have a function train test split train underscore test underscore split. So it will split the entire data set. So we are splitting the entire data set xy. Let the size be yeah, the test size be something you can give anything like text for size equal to 0.2. So actually it's not okay. We need to import that one. So I'm forgetting every time to import it. So from NumPy, so let's import from sklearn dot model selection import test train underscore test underscore split. Now it will. So this is how you split the data set for training and then testing for your purpose. Now let's load the model. So maybe I need to import that also. So I'm loading the perceptron model. So before 2 days we learned the linear regression and those things. Now I'm importing the perceptron. So perceptron means it's single perceptron. That is a linear model, but multi-layer perceptron is something like non-linear. So from the sklearn library, from the model, I'm importing what the perceptron function or the model. So Now the model is loaded into the variable model. Then you can, now let's fit. Next process is fit in the machine learning. So model dot fit the x comma y. So now the training is happening. So since it is very large data set, you can see it is taking more time. See, so this is how the training happens. So while we took the, what you say, set, I mean textual data set or the numerical data set from the linear regression, it took very just microseconds or nanoseconds. But here, while you train the image, each image is a matrix, and I shown you how the matrix is going. Each so you can see here, right? So each image is transformed as a matrix. The image individual pixels are considered as what you say, pixel values. So these are then transformed to the model. Okay. So now the training is over. Now, if you want, you can test using different images you can upload, but you can still predict the accuracy value, how much accuracy you got for your model. So you can have a function called accuracy underscore score. The small letters case. You can predict the accuracy also. So you're predicting the accuracy between the y test and the predict y. So you can see that. I think we did not import. Okay. Let me import the accuracy function. So everything is function nowadays. So we need to import it. So we can design our own metrics also. So from a scalar dot metrics, we can import accuracy score. Okay, so you need to before that one. So that is the thing. Okay. Then we're predicting the accuracy. The y prediction we predicted, and we have y test, so that we have splitted from the data set. So this model, that is the model we have predicted some, that we are comparing whether it is correct or not with the y test. Now let's check how much accuracy we can print the accuracy. Yeah, something like 88 point. So we are getting the 88 point. How to make it 100? So this is something you need to check. So we are getting here something like 88%. So how can we make it 100, something like that? So this is what you need to learn by diving into deeper. Okay. So we have different activation functions. We have different types of epochs while you train the models. So those things, hyperparameters, you need to learn. So let me come slides. So this is how you with different activation functions. So let me introduce what do you mean by activation functions. So let me take, okay. So activation functions in a biological, think of either active or non-active. So with this respective value, you want to pass something. Okay, so a perceptron uses many uh, functions, especially step activation function. You can see this is a step activation function. What is it's doing is it is passing the value after a certain limit. You can see here. So till some value it is not activating, and after some value it is activating. You can think of a binary classification. To a certain value it's dog. After that it is something like cat. So bias only actually tells us where the activation function happens. So you can think of function. So you have different types of activation functions like that. So why step or why other activation functions? So let me show you some other. So what is it actually? Activation functions. This is need to know into depth wise. So predicting cat or a dog or something else, what this activation is doing. So that you need to know. So in between, you can see here this equation. This is weight, and this is the input, and this is the bias. In cat versus dog prediction or any classification function, it helps the neuron decide is this a cat or a dog. So into respective values, it will take some. If the value is larger, it gives the signal that it is a cat, and that value you need to decide while training. So suppose the image features are ear shape or tail length or fur pattern or face shape. The neuron combines them like z equal to omega x plus c or z equal to something like that. Then after a value it gets activated. This thing after a respective value it is a cat or it's a dog. Till that value it is a cat. So like this it is you are formatting. So in this graph you can see the left side the neuron is off and the right side the neuron is on like a switch. So like biological analogy you can think that the neuron does not fire like weak signal or strong signal fires. So something you can it gives a one value if the neuron fires or a zero value if it does not fires. So this is something happening in the step activation function. So it's not it, after a respective value it's giving a different output. This is something like uh, a disadvantage in this one. So main function of the step function is it does not have a smooth function. So it's something like jumping to a next step, a sudden jump. And mathematically, we can say it is not differentiable. So I don't know how many of you are familiar with differentiation and those things. So here we cannot differentiate to learn more things. So maybe the algorithm like gradient descent cannot learn properly. So happening is the image you are passing into neural networks an activation function it needs to activate even though you get some output. Okay, so here you can see next function I'll show you it's something known as sigmoid function. So this is a function which activates at a respective time. So what about sigmoid function? It's a smooth function in neural networks. It converts any value into the number between 0 and 1. And the step function, before I show it just gives the input like 0 or 1. But here it's something I shown you this I think while I was teaching you the logistic regression. It maps the 0 1 value to between the 0 and 1 value. So this is called a sigmoid activation because it behaves like the probability. So in the negative side it behaves like almost like 0, and in the positive side it almost behaves like a 1. So here what you can see like it gives a different types of values. It's a S-shaped curve. So very negative it's near to 0 and positive near to 1. So sigmoid actually gives a smooth output. Unlike step activations, this helps the neural network learn using gradients. So you can take this differentiation and those things to learn this much things. Okay, so you can see that graph is something like a curved smooth function, which gives the probability output and good for binary classification. And then we have a problem like vanishing gradients. So you can see here we different layers we multiply with so here it gives x1 x2 x3 etc. Then it multiplies each input is having its own weights, that is w0 w1 w2 w3 etc or omega 0 omega 1. So whatever you can give. So then here you get like something like this is x, then this is z, means z equal to w1 x1 plus w2 x2 plus 3 x plus w4 x etc you will get. Then you are passing these things into an activation function. So that is actually what is happening. Okay, so you have a0 a1 etc w0 w1 etc. Then you are taking the weighted average, that is weighted average means w0 into a0 plus w1 into a1 plus w2 into a2 etc equal to some other numbers. And then it is from here it is passing to the next layer activation function where this is given. So to a certain value what you get, a can be dog, and from that value a can be so what is that value is determined by the training process. So here sigmoid value it's not something like steps, it skews the value. And what is the problem is for very large values if you're multiplying by 0.0001 and all, the gradients becomes very small actually, or the learning becomes slow. So because of this we use different activation functions. So you can think of the sigmoid or something like that. We have different activation functions. So one of the function is relu. So what is relu actually? So actually, what you're doing? So I said you're getting from the neural networks, you are getting a value a. Then you are passing this value to any function. So once the a is activated till the a value, some values, it you can think the you have for a cancer data set means you have a cancer. From that value onwards, you don't have a cancer. So it's something like classification. So now coming to the third activation function, ReLU, that means rectified linear unit. So most use this activation functions in deep learning today. So you can think to a respective point it is zero, then some linear values are coming. Like unlike step function, it is 0 and 1. Here it is something like 0, then 1, 2, 3, 4, 5, 6, something like that. For negative values, it's giving 0. And positive side is it's giving a straight line that is like a linear regression. So here the vanishing gradient problems, like I said, if you're multiplying by some small numbers, it is going to 0, right? So here it partially resolves it. So how means the 0 values it is multiplying and it is giving to a weak signal. It will be suppressed actually. So neural network learns using weight updates using derivatives or gradients, it's called. If the gradient becomes 0 means learning becomes very, very, very slow. So sigmoid, you can think when you observe the problem, x is very large positive, or ReLU, you can think x is very large positive or very large negative. Sigmoid output usually becomes something like 0 and all. So from here onwards, it's become very, very, very zero. In the graph, you can see it's near to 0. But ReLU means, I'm sorry, it's meant to just wait. Let me to my slide. So this is something I'll pass you the. Don't worry. So during back propagation and all, or while retraining or while you're taking the feedbacks, you are with different values, small values, like it multiplies it equal to 0. So this thing actually you are giving very tiny feedback and neuron cannot improve. So the layers learn extremely slow. So while ReLU helps means ReLU, you can see the function, right? I show you a function. So f of x is maximum of 0 comma x, which means you are giving either 0 or 1, but you have different values. So that is what is the main peculiarity of ReLU. Then we have activation functions, like different types of activation function. Many functions are there. So you can train and check like PQLU, then ELU, GLU. So this is to improve your precision and accuracy. You can use these things. So that is the main peculiarity here. Yeah, main you have different like tan edge. So these functions give different types of results, but these things you have to give as per your application type. So which activation functions give you best value? So that is you have to determine as per your applications or your training data set. So there is no special definition. This thing should be used for this one. You have to try it within different activation functions. So that depends. So thing most commonly for binary classification output, you can use sigmoid. For multiple class output, you can use there is an algorithm known as softmax. So it's checking by the probability. And higher layers are there, you can use the ReLU because for CNN deep neural networks, hidden layers very fast and simple and reduces, as I said, like vanishing gradient problems and works very well. So for the face recognition, object detection, YOLO, and ResNet, those like models, you can use the ReLU. And sigmoid is basically for yes no predictions like binary, like spam or not spam, cancer or non-cancer, you can use sigmoid. And if you have multiple classifications like cat, dog, horse, if you want to perform different classifications, especially in YOLO, it's very famous. So nowadays, every students are using this YOLO for uh, different classifications or object detections. So what is happening is we are using inside the YOLO. If you're checking, you can see a softmax activation function. Actually, no one used to check actually. So it converts the outputs into probability. Okay, then you have tan H, like older networks use it more, but usually better than sigmoid, you can use it. So I don't have time to explain more into, especially the transformers. ChatGPT use something like GELU. So that is an activation function. You ChatGPT and all. So mainly this Gaussian error linear units. So it's a high probable activation, popular activation function used in modern deep learning networks, especially this vision transformers, VITs and all. So instead of applying a hard cutoff like ReLU, it assigns exactly, like you can see this, instead of applying a hard cutoff, which assign exactly like 0 to negative inputs, GELU weights input bias on the values relative to standard normal Gaussian distribution. So that you get multiply the line by input by, I think, by smooth probabilistic probability that depends on the input itself. Okay, so this, if you need to understand, you need to know more mathematics, which we can have it later. So this is happening actually. So you can see the different functions. I have given the different uh, types of functions here. You can check what type of function is used for different activations and those things. You can check here. So you can see first is identity function. So that's, you can think of linear. So output equals to some linear values. So actually, a neural network just become a linear model and cannot co- uh, predict some complex values. Then comes the binary step function. So that you can think I have shown you. So it's used like old normal subsound, like you can think of just on off or 0 1 categories. So the main thing is it is not differentiable and the gradient descent cannot work properly. So modern deep learning rarely only use it. Then comes the sigmoid, you can see here. Sigmoid I have shown you in the logistic regression and all. For binary classification and all you can use it. Then you can see the tan H, so you can just zoom and check. So the picture is very small. Still has some vanishing gradient problems. Then you can see arctan, ReLU. ReLU is widely used in deep networks, which trains better. So it's like computer vision, YOLO, then that class, I mean, convolutional neural networks and all use these things. Then you have um, different types of activation. So these things. So why the derivative column is mainly, you can see here. So why is it neural network learn using back propagation? We have it. So back propagation needs the derivatives. So derivatives only. So what is a derivative? What do you mean by a derivative? You know, you don't know more into mathematics. I don't know. I'm not clear. So it's a imitative of the work of another twist. So where you can learn how much should weight change. So I said you right. The main thing is happening in the weights only. So each pixel or each input, why is it important or how much important it is, it's determining by the weights, or you can think as slope. So actually that is determined by the derivative. So I hope you know nothing. Derivative means the slope. Slope means the change. Change means how much y should change while x should change. That is the main. The step function you can derive. You can take the derivative. You don't know how much it's changing. But sigmoid you can change very small gradients. It is happening, and even other functions also. So and even ReLU, how much change is happening as per the slope. You'll get the slope. But here you won't get the slope. So that is main bigger thing in this deep learning or machine learning concepts. So that is mainly coming here. So the function behind neuron, I shown you the function. So this is something like happening a big layer happening in different calculation. You can check layer by layer, but entire calculation you cannot even imagine also. So especially the object detection, segmentation, those type of algorithms use this type of calculations, which is done in GPUs, and that's why we need GPUs with multiple cores. So what is happening? You can think here, right? You have an output, you have a weight matrix, you have the inputs, and you have the bias or the intercepts. So each and every layer, the calculation is happening, and then this you can think of an active function. That value, what you get, is passed to an activation function to determine whether the classification is which class and all. So you have to do it by layer, but you can't imagine how this is happening. So this Python is simple. So like you can think in layer one, you're getting, then you're passing into layer two, then you're passing into different layers. So basically linear algebra is happening here. So this is something you are known as, we have feed forward network. So I think that I have just have written. So you saw in the MNIST data set. So you have a in MNIST data set, you have a 28 by 28 pixel image, and you are predicting it as 5. So what is happening? This image you are mapping into this number actually. So this you can think as a label, and this you can think as an input. So here in hidden networks, what is it actually calculation? So you can see this handwritten digit recognition. Mainly it is passing to the multiple layer perceptron. So you have different individuals of perceptron happening the calculation. So how the calculation is happening, I shown you here. Matrix side, right? Yeah. So like this calculation is happening. So W into A, W into A, W into A, like this calculation is happening in each layer. So that is what is happening in deep neural networks also. So I'm sorry. Yeah, so that is what is happening in different types of images. So actually, what happens in the first layer, I shown you. The W is multiplied by the weight is multiplied by, how we will determine the weights, it's by training. But starting, you can give some random weights as initial weights. This is how you train. So with 0, 0, 0, then maybe the back question will adjust these things. So this is mainly the mathematics happening, whether you want to predict it, whether you don't want to predict it. So these things you have to try with different activation functions, which algorithms gives you best results. Okay, so this is how you do the things. So we'll go back to the collab and we'll try with different activation functions. Let me go to the collab. So we'll try with different activation functions. So let me take so okay. So here you can see we have taken the MNIST data using the fetch OpenML function in the sklearn library. Then we separated they have its their value, we separated the input value and y as output value, that is a target. Okay, so now we have done a normal signal layer perceptron. So since that is a very small result, now we'll try with some other sigmoid function. So let me go back. So I'll share you the code. Okay, so now let me just calling the function, that's it. Okay, let me call MLP classifier. So that is multiple layer perceptron, which you get some complex um, outputs. So you can define layers, number of hidden layers, how much you need. Even that also you can design. So I think it's here. So hidden layer sizes, it has given hundreds, and that's it. And give the maximum iteration is very low value. So for this I'm giving is, so for okay, activation function here. Let me use activation equal to log. So logistic means it's sigmoid itself. So in logistic regression, we use the sigmoid, right? So we just train and check which is the better value, because we can't predict it, right? Otherwise, we need to add more number of classifications. And before that, let me import the model from the sklearn. So this is how you do the trainings. So from sklearn, we take neural networks, import MLP class. So these things we teach to students and ask them to. So I'll see here. Now we have imported the model into. Sorry, it's already the training has happened. Okay, let me take the model to fit model 2 dot fit xy. So entire thing is happening like this only, xy. Then you're okay. We'll take it to. Okay, we have. I'm taking the entire data set, or you can take the X train and Y train. Before I think I have done a mistake. train white train. We are training white train. Okay, let it train. So it may take some time. After that, we can predict. We need to predict the answers. What is how much accuracy is it having? So model dot predict, model two dot predict. So next, we'll check whether we are having less accuracy or higher accuracy. Okay, so accuracy two. Let the training happen. Okay, it may take time. So learning, especially for bigger things and all, it may take time. And with what we are comparing the accuracy, we are checking with y test and y prediction. Y prediction. So y prediction is what you got after the training, and y test is what is there in the data set itself. Okay. So here y test means where we have taken, yeah, y test is this one that we are taking from the data set itself, from this library. And y prediction means we are predicting it from the model. So this may take time, like, so for deep learning, and you can give this project as assignment and students can do from their home. Okay, so it depends on the training and those things, and you can ask, compare these things also. It's happening fast, which takes more fast to train, which take more time to test. So it depends on the applications. So it's still running. So let it be there. Let me try with. So actually, this types of mathematical pattern is happening in the in the training. So the main thing is the weights and bias. Okay, the main uh, what you say, uh, main agenda of uh, deep learning is happening in weights and bias. You have to be very careful because that is the learning parameters. This x and y you are giving it from the set. Every neuron mainly does it, but the weights are like, suppose the cat or something like that uses the ear shape, whiskers, tail, fur. Neuron may learn that one actually, which is the important feature to predict the number is a 9, means to predict this. So you saw the data set, right? So I'll show you. So which feature it learned to predict the number is 6? Which feature or which input feature does it learn to predict a number is 5? Or which, so it depends on different application to applications. Or which feature of, or which pixel is it important to learn? So that is only determined by the weights. Okay. So these things you have to be careful. Weights and bias, it's some of the important terms. So mainly mathematically meaning means x will be coming from the data set, and y also, it's the, you are predicting it using the x and weight and then bias. So bias means you can think of it's a shift from the neuron output. Think of like this extra adjustment. And why bias is needed? Without bias, I said, like, line always passes through the origin. If you're thinking as a graphical way, with bias, the networks can shift. So how much shift it should give to get the accurate value? So that is determined by the bias. So that is something happening in the weights and bias. So maybe the first weight determines weight in the layer 2 tells us which is the first layer pattern should be combined. And the deeper we go, the more pattern we get arrangement in the different layers in the deep neural networks, and that's what happening. So something like feature computation, it operates directly in the feature computation. I think we are running out of the time, so yeah, the training has happened. So let me predict the accuracy score. Now we'll print the accuracy score. Yeah, we accuracy is improved to 94%. First we got, I think, 88%. 4%. Now let's try with, so that is with sigmoid function. Now let's try with what you say as uh, ReLU activation function. So we'll try a model 3 equal to, you need to compare MLP classifier. This we have already imported 100. So let it be 100. And the activation function is something like ReLU. You can give it ReLU. And the maximum iteration rate will be 20. So iteration also you can change. Okay. Now let's just fit it. Model 3 dot Hit experiment and let it. Yeah, now the training time will take. So this is how you predict something. Okay. So you can see the slide here. Let me take the slide. I think it is training is happening. It may take time. So here you can see for the second model we got 94%. Model we got 88 percentage. So by adding logistic regression, not logistic regression, sigmoid function, we got a 94% of result. So how we got? We are predicting the X test. We have images in this one, and you predicted some values for that one, and then you have Y test also. Y test means the images. I mean the not the images, the outputs which is there in the data set. So you're comparing both data set here. So now is model 3 with is very fastly training, and we can try to predict the accuracy also. So let me take this and copy paste. So this is something model 3 dot predict. We'll predict the Y prediction, and then we'll compute that also. You can see the accuracy. Yeah, it's 95%. So while using you got bigger percentage. So like have different activation functions like this. You have to compare and check which of my model with which activation functions gives me good result predictions. The here you are not displaying the entire data set, because displaying the 70,000 images it takes time. So inbuilt the GPU, you can try with different GPU. You have the different, if your data set is very big, you can try with the GPU. And if you can purchase the GPU from the Google also. So if you are giving like 4,000 rupees per month, you will get a GPU. If you have any, you will get the A100 and all. So it's very, very, very well worth with it. So that's it with neural network. I think I'm running out of the time. I think how, so next thing, how can we design a neural network is you can take from the next thing you have to study. So you have to compare this models. You have to compare different activation functions. You can squeeze the layers or increase the layers. So like that you can compare with different patterns. So that's it from my side. So I think I have given an overview of the neural networks and perceptrons and multi-layer perceptrons and activations and weights bias. If you want something else, means you can contact me and try. We'll see later. So till then, bye. So this is Yasser signing off. That's it. Thank you and have a nice day.